Okay, we are on our angled projectiles homework practice problems. We're going to start out with number 3 because y'all voted on number 3, kind of. One person said it loud enough to make me think it was voting. So, number 3, a kicker on the football field kicked the ball with an initial velocity of 18 meters per second at an angle of 35 degrees to the horizontal. Okay, so basically that first piece of information that they're giving us, the initial velocity, is that Vx or Vy or neither? Neither. That is our resultant velocity, okay? Because it's not telling us that it kicked the ball straight up. If so, we know that's our Vy. It's not telling us that it kicked the ball horizontally. If it did, we would know that that's the Vx. Instead, it said it is kicked at an angle, 35 degrees to the horizontal, right there, okay? So we know that we are going 18 meters per second at a 35 degree angle. So this tells us right now, because it's a right angle, that this can be our Vy and this is our Vx. So that's my initial setup. Immediately there are some pieces of information I know, because we're going to treat this angled projectile as two components, your y-axis and your x-axis component. So, by the way, just been a long weekend, so let's just do a quick review on your projectile parabola. My trajectory on one of these angled projectiles. Thank you. So some things that we already know off the bat is that when we use our equations to find what dy is, when we're using that time, remember we assume time up equals time down. We assume our dy, distance up, equals distance down. So that being said, our equations, we only are using it for technically half of our trajectory. Just like when we're doing our up-down, we had the ball, we threw it up in the air, and we said it stops and then turns back down again, how we're only using half of the trajectory. So be careful how the question is worded. If it's asking you to, this one here says, how long was the ball in the air? So it wants to know time up and time down. So we're going to find the time going up and the time going back down again. So technically, we're finding 2t for this one right here. Okay, so this one's saying how long will the ball be in the air? 2t. How high did it go? What is that asking us? Our dy. And then how far down the field will it land? dx. But keep in mind, when you're solving, dx is the range of this trajectory. But when you're solving using the equations we've been using, you're finding when you're solving for your dx, it's only got the t in it. So make sure you're using 2t. If not, you're only finding half of the range. We already said that those problems are set up that they're only half of the total trajectory. So we want the full trajectory if we want the full range. Okay, so this is time up and time down to get our dx for a angled projectile. Okay, so let's take a step back. How long was the ball in the air? So we're trying to find our t. We don't know that. Some other little points of interest on one of these angled projectiles. Your velocity on the x-axis is constant, so it's going to be the same. No matter where I am on this trajectory, my Vx remains the same. Not the case with my Vy, though. Your Vyi here and your Viy here are going to be the same. Right there and right there. The speed when it leaves the foot of this football player is the same as when it lands back on the ground again. Right before it hits the ground, I should say. It slows down, though, till you get to the highest point. So what's my final velocity? 0. My Vfy is 0. So I'm going to come down over here. I'm going to say my Vfy is 0 meters per second. I do not know my Viy. I do not know my time, and I do not know my dy. That is a lot of unknowns, isn't it, gang? But fear not, because I was given enough information over here to find my Vy. And I'm going to do that because look over here. I know I'm trying to find my opposite, and I have my hypotenuse. So I want to find my opposite, and I have my hypotenuse. So what trig function here? Yes, saw. I'm going to say saw, whatever. So I'm going to use sine of angle 35 is equal to my opposite over my hypotenuse in order to solve for Vy. I gotta just get my Vy by itself at this point in the game. So I'm gonna multiply both sides by 18. Okay, so Vy equals 18 sine of 35. You're fast. What'd you get? Okay, 10.32, good. So now I can go over here and fill that in, Viy, 10.32 meters per second. Well, do you see a formula that I might be good to go behind me? By the way, I'm missing one known over here. What am I missing? Gravity. Y'all can do negative, that's fine. Okay, so I'm going to find my time. What did I say I need to do? Help me with the equation. Yay.
Equals Vy plus gravity
Times time. Okay, so since this is an angle projectile, can I treat it like my up-down projectile? My final velocity is Sandra? I solved for this, and I can plug that in there. 10.32 minus 9.8 times t. So I'm going to subtract. I'm going to subtract minus 10.32 from both sides. I don't know why I put the pencil there. It did. Are you with me so far? I didn't realize I was off the screen. Sorry. Let me see. Okay, so now I'm solving for my time. Time is 1.05 seconds. Okay, but let me go back and read the question to make sure. How long was the ball in the, where am I? Number 1? Yeah. Nope. Oh yeah, I'm on number 3. Yep, how long was the ball in the air? So it's 2t, isn't it? So let me double my time real quick down here. 2t equals what? 2.1 seconds. And now I can go back and plug this in. I have my 2.1 seconds. I'm going to do some indicating that this was my answer for part. I should put part A there, shouldn't I? Silly me. That way your teacher does not get a big old wrinkle in her middle of her eyebrow. Let me know where your answers are. Circle them for me. So it's 2t. Okay. So we said that our ball in the air was 2.1 seconds. 2t equals 2.1 seconds. It was pointed out to me that up here I had just a plain t by itself was 2.1, and that's incorrect. Our 2t is 2.1. Our regular t, which we're going to need at some point, is 1.05. Which we want that to find our dy, because we only need to go up for our dy. We need to go up and down to find our dy. For the next one, how high did it go? Okay, so now we are trying to find our dy. So on letter B, don't mind this, I was doing if we were going from an angle from the vertical, I was trying to listen to what that would look like. But anyway, part B, how high did it go? So now we are indeed trying to find our dy. Is the question of the hour. Well, we can use what handy-dandy formula? Okay, so we're going to get 1/2 times, you can do negative 9.8. Or if you do positive, that means you're just pretending that you started from the bottom instead of from the top. If you do negative, that means you're starting from the top going down. It doesn't really matter. The dy is the same either way. So I don't care if you do negative or not on this one. Times t squared, we said was, oh, okay, this is regular t, by the way. Okay, just t, not double t. Did anyone get dy equals 5.4? Yay, 5.4 meters. And watch what I'm going to do. Yes, thank you. Okay, part C says, how far down the field will it land? So So I want to know the range of this bad boy, of how far the range of my football. Okay, so I'm going to go up here and answer my dy is 5.4. How far down it goes. So what am I asking for? Dx. Okay, remember we need for x-axis, we need dx, we need vx, and we need time. Okay, do we need regular time or do we need to double the time it takes to get to the top? Okay, we need to double it. Regular t is just the time it takes to get to the top of the trajectory. 2t is the time it takes to go up and down again. What goes up must come down. So make sure we're using our double t, time up and time down. So I'm going to say t equals what? Okay, now, am I ready? What's my formula? Okay, sweet. I can go ahead and plug in. Time is 2.1. Okay, my d's already solved for. My vx is... Oops, I don't have that, do I? No, how do I find it? I need to find my vx. I'm going to go all the way up to my handy dandy triangle up here. And I'm trying to find I have my angle, I have my hypotenuse, I'm trying to find my adjacent, right? So I'm trying to find my adjacent, and I already have my hypotenuse, so what is that? Adjacent hypotenuse. Remember, tan is opposite adjacent. And so right now, I'm trying to find my adjacent, and I have my hypotenuse. So I'm actually going to do cosine of what angle? 35 equals adjacent, which we are saying is our Vx, over our hypotenuse, which is 18. So 18 cosine of 35 degrees equals Vx. What is your Vx equal? Let's them off the screen. Yes, 14.7 times 2.1. So over here, when I was doing my list, I'm going to pop this back up here, 14.7 meters per second. My total time was really 2t, so it was 2.1 seconds. And so now I can do my equation, dx equals bx times time. And dx equals what, gang? Did I get 30.9? Can we remove that 30.87? That's fine too. That's fine. 30.9 meters. Boxing it up. Woo! Did everyone get that? Yay, I'm right. Awesome.